Vectors. Example 2. A commuter airplane starts from an airport and takes the route shown in figure below. The plane first flies to city A, located 175 kilometers away in a direction 30 degrees north of east. Next, it flies for 150 kilometers, 20 degrees west of north to city B. Finally, the plane flies 190 kilometers due west to city C. Find the location of city C relative to the location of the starting point. Now, let us look again at the vector diagram given in the question. Okay, from the description given and from the diagram shown there, we have three vectors A, B, and C given to us, and we are asked to determine the magnitude of the resultant vector R from the diagram. Okay, so for this example, we will solve it using the component method. Okay, firstly, let us write the equation for these vectors in angle method. Okay, vector A from the question given to us as 175 kilometers north of east. If we convert it into angle method, it is 175 kilometers positive 30 degrees. The vector is situated in the first quadrant. The second vector B, given to us as 150 kilometers west of north, in angle form, we will have 150 kilometers 110 degrees, which is in the second quadrant. And the third vector C, given to us as 190 kilometers due west, in angle form, it is 175 kilometers 180 degrees, which is in the third quadrant. Okay. Now, let us resolve these three vectors into its x and y components. Okay, so as shown in the table there, okay, for vector A, we resolve it using the equation 175 cos 30 degrees. And here note that the angle used in the question must be the angle that is the direction of the vector, which is always measured from the positive x-axis. Okay, so for the x component, we have 175 cos 30 degrees, and for AY, it is 175 sine 30 degrees. Okay, and using the same method for vector B, we will obtain Bx and By as shown in the table as to vector C. Okay, so the Cx is obtained as negative 175 kilometers and Cy is 0 from the method. Okay. When we have resolved all the components of the three vectors, we sum up the x component for the resultant vector, which is Rx. We have it as negative 74.75 kilometers, indicating in the horizontal axis, the vector R is directed to the left. Whereas for the y component of the resultant vector Ry, we get the value of 228.45 kilometers, indicating the y component of the resultant vector is directed along the positive y-axis. So this means the resultant vector R is situated in the second quadrant. Okay, and then using the equation for magnitude, Rx square plus Ry square, we substitute the values obtained from the table above. to get the value of 240.37 kilometers, and the direction for r, substituting the values of rx and ry in the equation, we get the value of theta to be negative 71.88 degrees. Note that this angle is not measured from the positive x-axis. It is measured from the negative x-axis. Okay, so the value of the angle, which is the direction of r, must be taken from the positive x-axis, that is 180 minus 78.71.88 degrees, where we will get the value is 108.12 degrees in the second quadrant.